Hello everyone, this video is about the formula derivation and integration. Integration is reverse differentiation. So if we can differentiate, for example here, y equals sin x, the derivative is cos x, this is called differentiation. The reverse process, if y prime equals cos x, just like this of course, the y is of course sin x, so just like this. And this process is called integration. So there is no formula derived here, it's just the opposite process. So same thing here, if y equals cos x, the y prime is minus sin x. So if we have y equals minus cos x, the y prime is of course minus minus, which is plus sin x. So if the y prime is sin x, the y is minus cos x. So this is called integration. So the integral of sine is minus cos, the integral of cos is sine. Here's the list of integration that is pretty simple, and you don't need to use or you don't need to derive anything. Just look at the differentiation process and reverse the process. Now what about the modulus? Here you see a modulus sign. The modulus in logarithmic integration. If y equals ln x, well, of course this is possible only if x is positive, of course. The y prime is 1 over x. We know this in differentiation. Now if the y is ln minus x, and of course in this case the argument must be positive, remember, so x must be negative. Now the y prime is 1 over minus x times the derivative of minus x, which is minus 1. So in the end we get exactly the same, also 1 over x, also 1 over x. So the reverse process, the integral of 1 over x dx therefore can be ln x if the x is positive, or it can be ln negative x if the x is negative. So to simplify this, we say that the integral is ln absolute value of x. That's why we have the modulus function in the logarithmic integration. And now for the special functions. Inverse tangent x is, the derivative of inverse tangent x is 1 over 1 plus x squared. So we know this in differentiation. And if it's x over a instead of x, then of course this is also x over a, and we have to multiply by the derivative of x over a, which is 1 over a. Apply the chain rule here, and if we simplify here, we square the both parts of the fraction, and we multiply by a, the denominator, times a, and if we again multiply both parts of the big fraction by a, we don't have fractions in fraction anymore. Now we have a over a squared plus x squared. So if the y equals almost exactly like this, but if we multiply this by 1 over a, of course we're gonna have to multiply the y prime here by 1 over a, so the y prime is 1 over a squared plus x squared, or x squared plus a squared, same thing. So this is why the integral of 1 over x squared plus a squared is 1 over a inverse tangent x over a. This is the MF19 formula. So we can derive this using reverse differentiation from inverse tangent, or we can just do it from scratch. The integral of 1 over x squared plus a squared dx. The key is to draw this kind of triangle. You see, we have to set the hypotenuse to be here, because x squared plus a squared, this is just like the hypotenuse. So this is x, this is a. You can also use this is a, this is x. You can just flip or switch it a and x. The final result would be exactly the same. So cos alpha is adjacent over hypotenuse, so a over this. We can move or divide both sides by a. We can square both sides, we get this. So we have the expression for 1 over x squared plus a squared. And now if we just look at the x and the a, tangent alpha equals opposite over adjacent, so x over a, and this means x equals a tangent alpha. The dx d alpha, we differentiate this with respect to alpha, we get secant squared. The dx is therefore a secant squared dx, I mean secant squared alpha d alpha. But secant is 1 over cos, so we can say a over cos squared alpha d alpha. Now let's substitute everything. We replace the 1 over x squared plus a squared with this. So with this cos squared alpha over a squared, and we replace the dx with a over cos squared alpha d alpha. And of course cos squared cancel out, we have only 1 over a. The integral is simply 1 over a alpha, because this is d alpha. And the alpha is, from this definition of tangent x over a, the alpha is inverse tangent x over a. So this is the alpha, inverse tangent x over a. So that's how we derive the formula using another method, and we get exactly the same result. And now this is the other special formula in integration standard integration in MF19. 1 over x squared minus a squared. Well, we can just use partial fractions here. 1 over x squared minus a squared is the same as 1 over x plus a, x minus a, and then we can use the distinct linear, it's gotta be in this form. We multiply both sides, we get this, and we plug in x equals a, x equals minus a, we get the b value, the a value. So this is what we get in partial fractions. And then we can pull out the 1 over 2a out of the integral, and then we can integrate minus ln plus ln this, and then we can just we're just switching the order here, the positive one first and then the negative, and minus means division, the quotient rule, and we can just combine the absolute value. That's it. So this is the graph of 1 over x squared minus a squared. So as you can see, we have vertical asymptotes at plus minus a. So we have a restriction. If you want to use this formula, the x cannot be plus or minus a. Now in your MF19, it says the restriction is x is bigger than a, right? And in my opinion, I don't agree with this restriction that x must be bigger than a, because in my opinion x can be smaller than a, no problem, as long as it's not exactly the same as plus or minus a. So I think the formula means, or what the formula actually means is, if we have no absolute value, or if we simplify, or if we just use parentheses, just simple brackets, then yes, x must be bigger than a. But since obviously we have absolute value, also on the MF19 formula you see we have absolute values, there is no need to use this restriction x is bigger than a actually. So I think there's I don't understand why the MF19 uses this restriction for this formula. There's no reason in my opinion. And now we have x squared minus a squared. So yeah, it's almost the same as the previous one, but this time we have the opposite order here, so we can just multiply both sides by negative, so we can swap or switch the order here. And now for this minus, we can pull it inside the ln, and to the power of minus 1 means 1 over, we can flip, and after flipping, you remember we have absolute value here, so we can just multiply by minus and the final result will still be the same. And this minus multiply with the denominator, we switch the order in the denominator, and of course we can switch the order in the numerator, and we get the formula on MF19. And again, x cannot be plus or minus a. And in MF19 again we have this kind of strange